My name is Sunday Okoyemi, a student at the University of Lagos, studying Industrial Relations and Personnel Management.
My name is Keshiro Devi, a student of the University of Lagos, studying Industrial Relations.
My name is Abdullahi Sadebiti, a student of University of Lagos, and I'm studying Industrial Relations and Personnel Management.
My name is Ikechukwu Prosper. I am a student of University of Lagos, studying Industrial Relations and Personnel Management.
My name is Odede Inifemi Joseph, a student of University of Lagos, studying Industrial Relations and Personnel Management.
Okay, now, so we'll be talking about the hardware components. So when we talk about the hardware, we'll talk about the physical part of the computer. So the physical part of the computer comprises of 4 components, which are the inputs, outputs, the storage, and the processing. So let's talk about the input first. So the input device are a device that provides data and control signal to the information processing system. Examples are the mouse, joystick, keyboard, scanner. So now, these devices are actually very, very important to an organization in terms of them being able to process and to send information or data. So the next one will be the output device, which talks about the which receives data usually for display, projection, or physical reproduction. Examples are the monitor, printer, screen projector, headphones, speakers. So the next one is the processing device. So which you have the CPU, which is called the central processing unit, which handles information processing, calculation, and control tasks of that. It is also considered as the brain of the computer, as it performs all types of data operation, which also it has 3 components, which are the memory or storage unit, the control unit, arithmetic unit. Okay, so the last one is the storage device, which is an hardware that is used to store, port, and extract data files. It can be used to store information or data permanently or temporarily. And we also have different types, like the primary storage device, which is the one with the computer, and we have the secondary storage, which are the external, which examples are the hard disk, CD, DVD, pen, or flash drive. So the business factors that affect storage decision include the access, the speed, cost, safety. So organizations must have their most important data easily accessible. Examples of how files can be stored are kilobytes, the megabytes, the gigabytes, terabytes, the petabytes, the exabytes. So that's how the files are stored. You have example are all these messages you send, videos, and everything. So that's how files are stored. Thank you.
So I'll be talking about software. Software can be defined as a data or program that is used to execute the computer and also perform some particular task. So we have 2 types of software. We have the application software and the system software. What are application software? Application software can be defined as a type of software that performs a specific task for users. We have different examples of application software. What are the examples? We have the web browser, we have the word processor, we have the communicating platform, and so on. The second type of software, we have the system software. What is system software? System software can be defined as a type of software that runs the computer hardware and the application software.
Examples of a system software is operating system, firmware, the computer language translator, and the system utilities. The operating system is the best example of a system software because it manages all other computer programs. So how does a software work? How does it work? We all know that all software provide the direction and data that a computer needs to work and to meet users' needs. So how does a software work on an application software? How does it work? We all know that all applications on a computer cannot run on its own, but they required a computer's operating system along with other supporting system software programs to work. And these desktop applications are installed on the user's computer hardware, hard drive, and do not need any internet to work. However, this desktop application must adhere to the requirements. It must comply with the requirements of the hardware devices that they run on. For web application on the other hand only required internet access to work. It can't work without the internet connection. And also Users can launch the web application from devices that have a web browser. Users can launch the app from Windows, Mac Linux, and any other type of operating system. So how does the software work on a system software? How does it work? How does the system software work? The system software, we all know that it sits between the computer hardware and the application software. And the users of this application do not really interact with the system. They don't really interact directly with the system software because it works in the background. It runs in the background, handling the basic function of the computer system. And also, system software executes when a computer system is boot up and continue running as long as the system is on. So how does software is created? So we look at programming and software. Software can be created through programming language. So computer programmers use program software to write code. Programmers also use this software to enable a developer to develop, write, test, and debug other software programs. Examples of program software include assemblers, compilers, debuggers, and interpreters.
I'm talking about network. A network is a group of two or more electronic devices that are interconnected for the purpose of exchanging data and sharing resources. Examples are computers, phones, printers, and the like.
So the main task of a network is to provide participants with a single platform for exchanging data and sharing resources. This task is so significant that many aspects of everyday and the modern world would be unimaginable without networks. For instance, network is transforming the workplace through internet and wireless computing. A real life example is an organization or a workspace that uses computers. Like without the network of computers, without the network of a computer, it will be very difficult for a team to work on a project since there will be no common place to share or store digital documents and information. Everyone basically uses networks. Like we use network one way or the other because the internet, online search, email, audio and video sharing, live streaming, and the likes all exist because of networks. So some benefits of networking is it allows one to implement security policies. It allows multiple users work on a single project. It allows one to track or monitor the use of resources. It also allows us to share data and resources. Networks basically makes use of transmission media. The three major wired media are the twisted pair wire, coaxial cable, and optic fiber. The twisted pair wire are the insulated copper wires, also used for ordinary phones. They are the most common wire media, partly because the phone companies already installed them for voice communication long before they were used to transmit digital data. Twisted pair wire contains multiple pairs of cables twisted with each other. The cables are twisted to minimize interference between each other. A twisted pair wire can transmit data only for a short distance and the speed is slow. The advantages of a twisted pair wire: it is flexible and lightweight. It is easy to work with and it is easy to install. It is readily available. Disadvantages: it offers very poor security. It produces various signals like noise. Another example of the wired media is the coaxial cable. The coaxial cable are common in homes because the cable TV companies install them to carry television signals. The coaxial cable can transmit data at a faster speed for a longer distance than a twisted pair cable. It has disadvantages, which is it is expensive, it's heavier, thick, and difficult to bend compared to twisted pair cables or twisted pair wire. The third example of the major wired media is the fiber optics cable. The fiber optics cable is also called the optical fiber cable. It is the fastest transmission media. The fiber optics cable is popularly used for long-distance communication, telecommunication networks. It transmits data in form of a light signal. It contains multiple air-like fiber made of glass and plastics. Optical fiber is commonly used in aircraft to reduce weight. Solar energy is also an example of optical fiber. Another type of transmission media that networks make use of is the wireless media. The wireless media can be defined as a means of communication in which data and information are transmitted from one place to another wirelessly without any use of electrical conductor as a medium. The most common wireless technologies use radio waves. Wireless media carry electromagnetic signals that represent the binary digits of data communications using radio or microwave frequencies. Examples of wireless media: Bluetooth, Wi-Fi, short for wireless fidelity, satellite.
I'm talking about network basics, and network basics are actually the way the computer are connected to the internet. And okay, so we have three basically. We have the LAN, which is the local area network. We have the packet switching, the voice over internet protocol, which is the VoIP.
Okay, going forward, the local area network, which is known as the LAN, typically connects computers, printers, scanners, and other devices in a single building or home. Connecting computers to other devices to transmit and receive digital information involves creating a network actually. Now, on packet switching, most networks use packet switching in which strings of data are broken into segments called packets before they are transmitted. The packet contains information about their destination and position in the whole message, and they are reassembled at the receiving end. Unlike the voice over internet protocol, it refers to technologies that make the voice communication across network using packets feasible, including over the internet. This disruptive innovation started out, as many of them do, attracting people with small budgets and lots of patience for drop calls or bad audio due to the busty way packets travel. More, I'll be talking about the types of network, and the two major types of network are the client server and the peer-to-peer network. The client in a client server network can do more or less work depending on how the software is designed, but the trend is to reduce the client workload. For business software, this eliminates the need to install and configure special software on all the different types of clients throughout an organization. About the peer-to-peer network, the highly decentralized approach is actually called the peer-to-peer network, in which there is no central server and computers that share files, printers, and an internet connection with one another. The network for homes or small offices are often set up in this way. The nodes on the decentralized network are peers in the sense that each one can offer services to the others and none is centralized server. On network protocols, we have three major network protocols, which are the Ethernet, the TC and IP, and the wireless. So I'll be taking the Ethernet first. The Ethernet protocol is the most popular and oldest LAN technology, that's the local area network. So it is more frequently used in local area network environment, which is used in almost all networks like offices, homes, public places, enterprises, and the universities. Ethernet has gained huge popularity because of its maximum rate over longer distances using optical media. The second network protocol is the TCP/IP, which stands for Transmission Control Protocol, Internet Protocol, and it is a suite of communication protocol used to interconnect network devices on the internet. TCP/IP is also used as a communication protocol in a private computer network, as an intranet or as an extranet. The third network protocol, which is the wireless protocol, determines how the electromagnetic spectrum is used to transmit data. A family of standards called 802.11 is widely used for Wi-Fi connections on this network protocol. The future for wireless, with advances in Wi-Fi and cellular, is bright and offers much promise, not just for businesses and consumers, but for people in developing countries.
So I'll be talking about the enterprise architecture. The enterprise architecture is the big picture for the organization, the blueprint that describes the current environment and the target environment the organization hopes to reach to achieve its mission. It also includes a roadmap for transitioning from the baseline to the targets to help managers make better decisions that focus on long-term benefits and not just short-term gains. The architecture encompasses the people, technologies, processes, and data that make up information system.
An enterprise architecture consists of four main components, namely business mission, data architecture, application architecture, technology architecture. Business mission is a brief description of an organization's purpose with reference to its customers, products or services, markets, philosophy, and technology. Data architecture describes how data is managed from collection through to transformation, distribution, and consumption. Application architecture describes the patterns and technologies used to design and build an application. Technology architecture is the overall design of a computer system, the logical and physical interrelationship between its components. Now, for an enterprise architecture to work, it needs guidance. And by guidance, it needs an enterprise architect. The task of creating and guiding the architecture is often led by an enterprise architect. This position requires a person with a deep knowledge of the organization's mission and strategy, clear understanding of how different ICT architectures can support the company's goals. The architect's sole role is to lead the effort, communicate enterprise architecture concepts, and coordinate decision making so the organization stays on track. The architectural shifts now on the way have a major impact on industries, organizations, their employees, and their customers. Now, moving forward, the entrance of new competitors into the market as well as the old guard has made competition hard. Now, companies, organizations are having to evolve their enterprise architecture to keep up with new ICT developments so as not to lose customers and lose their share of the market. Challenges moving forward has led to improvement as users now seek clarity on the product and future features.